Hey everyone, welcome 7th graders. I am so pumped to be here with you today because we are tackling your assessment, review, and transfer video overview. Yep, to be incredibly precise, and just to get our official mission logs totally squared away for this explainer, we are looking at the exact file, assessment, review, and transfer video overview, STEM at STEM It, Unit 07, Lesson Pack 02, Assessment, Review, and Transfer Video Overview. We're going to make absolutely sure you are 100% ready to crush your HTML structure and accessibility mini project.
Okay, let's dive into this roadmap. We've got 4 clear steps today. 1. The design misconception. 2. Evidence on structure and accessibility. 3. Application, assessing your project. And 4. Transfer into human-centered design. All right, let's go. Section 1. The design misconception. Looks aren't everything.
So, I've got to ask, is web design just about making things look pretty on the screen? Seriously, I want you to really think about that for a second. When you're sitting there building your HTML mini project, are you only being graded on your visual output? Like, are we just looking at the layout, those flashy graphics, or the color scheme? Well, let's break this down, because honestly, this is where so many students get tripped up. It's a huge myth that web design is only about visual aesthetics and colors. Actually, scratch that. The reality is way deeper. Web design is fundamentally about the underlying machine-readable structure and accessibility. You see, true design involves that unseen code, that invisible foundation. That's actually a crucial part of your mini project, and you guessed it, exactly what you're being assessed on.
Which brings us to Section 2, Evidence, Structure Meets Accessibility. To prove why this matters, let's jump straight into the source material. According to MDN Web Docs, the crucial point is understanding semantic HTML. Semantic HTML is basically HTML written properly to define the semantics, or the true meaning, of your content in a totally machine-readable way. And this is absolutely vital for accessibility. It literally means that the tags you type give the text its fundamental structure, so browsers and assistive technologies actually understand what they're looking at, rather than just hitting a giant confusing wall of text. Let's see how this actually maps out side by side. On the one hand, looking at MDN Web Docs, which focuses on structure, we see that specific HTML elements, like the video tag or the table tag, define the true meaning of the content. On the other hand, looking at the W3C WCAG guidelines for accessibility, we find the strict rule that web content must be accessible to people with disabilities. It clearly states the code itself defines both structure and presentation. Do you see the connection? Proper code structure directly satisfies those accessibility principles. This basically proves that writing good, clean HTML is exactly what makes the web usable for everyone.
To really lock this evidence in before we move on to applying it, check out how the W3C actually defines web content. It's an equation. Web content equals natural information, like the text you read and the images you see, plus the code or markup that defines its structure. You can't separate them. The code itself is a critical, inseparable part of the actual content. It's the whole shebang.
Moving on to Section 3. Application, assessing your project.
Let's move to and see how this builds using a claim evidence reasoning, or CER, framework, and apply it directly to your exact assessment task so you can build a rock-solid project. Here is your step-by-step game plan. Step 1. Identify your input or evidence. This is where you literally point out the specific HTML semantic tags you used in your code. Step 2. Explain the model or pattern. You're going to explain how your document's underlying structure actually maps to and follows those W3C WCAG guidelines we just talked about. And step 3, identify the output or conclusion. This is where you get to demonstrate that your structural choices resulted in a compliant, perfectly accessible web page. It's a super logical flow, right? Proving your code input led directly to an accessible output.
But hold on, we have to think critically here. Because let's face it, technology isn't infallible. There is a specific limitation, a real uncertainty to this whole process. Automated accessibility checkers simply cannot catch every single coding issue. No way. You can't just run a quick software tool and assume your code is 100% compliant. Because of this limitation, a human or evidence check is strictly required for your assessment. A manual screen reader test or getting a peer review from a classmate is a completely vital part of verifying your accessible code. You always have to verify what the machine tells you. Finally, Section 4, Transfer, Human-Centered Design.
To really elevate your mini project from just a middle school assignment into a real-world tech superpower, we look to the Computer Science Teachers Association, or CSTA, standards. And this brilliantly illustrates the point. Quote, "Computer science is the study and human-centered practice of using data, algorithms, and computing systems to solve problems, an ethical, responsible, and human-centered practice." Think about that. Your accessible HTML design isn't just about checking a box to get a grade. It transfers directly to this massive idea of ethical, responsible computing that serves incredibly diverse groups of people.
And you know what? This also connects your newly learned skills right back to the ISTE standards for students. By considering these design constraints to actually solve accessibility problems, you are stepping up as an innovative designer. By demonstrating empathetic and totally inclusive interactions online through your code, you become a responsible digital citizen. And by examining multiple viewpoints to ensure your site works for people with disabilities, you're acting as a true global collaborator. You aren't just coding, you are becoming an empowered learner who builds for absolutely everyone.
So as you wrap up and finalize your mini project, I really want to leave you with this provocative thought. How will you use your new structural and accessibility skills to design responsibly for the real world? Let that question guide your keystrokes. Thank you so much for joining me for this explainer, assessment, review, and transfer video overview, STEM It, Unit 07, Lesson Pack 02, Assessment, Review, and Transfer Video Overview.